In this mini lecture of the Soil, Slopes, and Stream series, we'll talk about rivers and watersheds, and we'll address the question of what is a river. In the next few lectures, we'll talk about river form, function, and services. This first mini talk is an overview of river processes, and we'll get on the same page with respect to terminology. To understand rivers, you first have to start at the start and understand where we find water. Earth is called the blue marble, and water makes up 70% of Earth's surface. But this only represents a small volume compared to the entire size of Earth. If you were to gather up all of the water on Earth, including the water in the oceans, ice caps, lakes, rivers, groundwater, atmosphere, and also in plants in your own body, it would be represented by this largest blue sphere in the right-hand image. Its diameter is 860 miles, which is the distance from Salt Lake City to Topeka, Kansas. And this sphere would have a volume of about 300 million cubic miles, or over 1 billion cubic kilometers. It might sound like a lot of water, but it only makes up a very, very small fraction of Earth's whole mass or volume. All of this water together is only 1/1,000,000th the size of the Earth's sphere. And only a tiny, tiny amount of this water is fresh, because most is in the salty oceans. If you removed the ocean water, the fresh water would be the small sphere that's seen over Kentucky in this USGS image. But 99% of the fresh water that's in that middle sphere is too far below the ground surface and inaccessible to humans, and only 1% is near or at the surface as lakes and rivers. This small amount of surface water, 1%, is barely visible and shown as the tiniest sphere, just a dot, floating over Atlanta, Georgia. Despite its tiny volume, this water is critical for sustaining life as we know it. It also moves and flows across the land surface, playing a huge role in the evolution of the Earth's surface that we see in our backyards, towns, travels, or from space in the beautiful blue marble. If you'd like a basic primer on the water cycle, then check out this summary from a video of the National Science Foundation. And you can also check out this video of how water cycles through human, food, and energy systems. So what is a river? A river is a naturally flowing and channelized body of water. It moves and flows downhill under the force of gravity. Streams, creeks, brooks, creeks, and other terms are often used to describe small watercourses, while the term river is typically reserved for large ones, but there are no meaningful guidelines here, and the differences are just in the eye of the beholder. The channels through which rivers and streams flow have a variety of different shapes and sizes, such as you see here. They can be wide or narrow, deep or shallow. They can flow over rocks or over fine sediment. And the shape of the river also changes as it moves downstream. It can be straight or very curvy and meandering. If you were to ask most people the role of a river, they'd say it's to transport water. And of course, rivers do so much more. They connect ecosystems and people at a variety of different scales, and they communicate with hill slopes and soils, sometimes telling them what to do. Rivers can be kind of pushy. Rivers also transport sediment, and they erode their beds in some places. The erosion within a river is often termed incision. Rivers can also deposit sediments in some places, and through flooding, they can pose really significant natural hazards to humans. Typically, small streams flow into larger streams and rivers, and for example, here we see the Esopus River in New York, with a small tributary entering it. The term tributary isn't size dependent. Large rivers can flow into even larger rivers, and there you still have a tributary of those largest rivers. Stream order is a method for classifying or ordering the hierarchy of natural channels. There are a number of different classification schemes, and I've shown one here, but in general, stream order correlates well with drainage area, and small order channels, such as this little tributary here, flow into larger order channels, such as the Esopus River in the foreground. The base level is the level below which a river or stream cannot incise. Every stream and each point on a river has its own base level, and it's set by what is downstream, because streams flow downstream. For example, this point on a river cannot erode or incise beneath its downstream point, and this tributary cannot incise below the larger order river that it's entering. Or it shouldn't if everything goes to plan, and landscapes love exceptions, so sometimes nature is super weird. For example, mountains can go up, valleys can go down, they can drop, and huge things can happen as landscapes reorganize. Watershed is a really important term for rivers and river flow, and it's the area that contributes water and sediment to a river or stream. The water in a watershed could flow at the surface or as groundwater, and watershed is sometimes called a catchment or a drainage basin. Drawing or defining a watershed requires selecting a point on the landscape. For example, here I've outlined the watershed for this point along a stream. We can also define a watershed at a really large scale. Here's a map of the major watersheds of major rivers in the continental United States. Each color shows the upstream area of a large river, defined at the point of either their outlet or confluence with an even bigger river. For example, here's the Missouri River drainage basin, as defined at its confluence with, or the point where it enters, the Mississippi River. So the Missouri is part of the entire Mississippi River watershed. The Mississippi River watershed shown here is the upstream area of its outlet to the Gulf of Mexico. Watershed thinking and a watershed perspective is important, since a river is a system and it reflects everything up above it. The rain and snow that fell across the catchment, the way groundwater flowed, the ecology, the land use, etc. And watersheds don't care about socio-political boundaries. Understanding rivers, maintaining clean water, and ensuring equity and access requires watershed thinking. And I encourage you to follow this link to learn more about the idea of granting legal personhood to water. It's a not so radical perspective that's rooted in water rights and water's rights.